Welcome! In this lesson, we will be learning about valence electrons. So in an atom, the outermost electron shell, the principal energy level, where n is the greatest, is called the valence shell. Electrons that occupy the valence shell are called valence electrons. And we care about these electrons because they tend to be the ones, because they're the furthest out on the atom, they tend to be involved in the formation of bonds. So for any atom, we can determine the number of valence electrons by looking at the electron configurations. So we have our electron configurations on the periodic table, and the last number in that electron configuration will be our total number of valence electrons. And this is true for the groups 1, 2, and then 13 through 18. So on the top of our periodic table columns, they're labeled with group numbers. So for the first two columns and then the ones all the way over to the left, this rule, the last number in our valence electron configuration, will be our valence. So for cesium, if we look at our electron configuration from the periodic table, it's 2, 8, 18, and 1. The valence electron is going to be this last number here. So we can say we have one valence electron for cesium. For aluminum, if we look at the electron configuration, the last number there, 3, is the number of valence electrons that aluminum has. Same thing for antimony. Our last number here is 5. So we have 5 valence electrons for that atom. And then for iodine, it's 7. Right? So we can always look at our electron configuration right on the periodic table and know exactly how many electrons are in our valence shell. So we can draw Bohr models for atoms and ions using our electron configurations. So for magnesium, we're going to have 12 protons, and in a neutral atom, we'll have the equal number of electrons. And our electron configuration we can get right from our periodic table. So it's 2, 8, 2. And I can draw the Bohr model for this atom. So I'll do my nucleus. Then I've got 2 electrons in my principal energy level of 1. I've got 8. In my second shell, and then I'll have 2 out in my third shell. We can also do this for an ion. So a magnesium ion will have 12 protons, but only 10 electrons. So when we're thinking about the electron configuration for this isn't on the periodic table, we can figure it out. So electrons, when they leave, are going to leave from the last shell that they entered. Right? So here we're going to lose our electrons from our last energy level. So we can write our electron configuration as 2, 8, 0 to indicate that we've lost electrons from that shell. Or we can just leave the 0 off. But then we can draw our Bohr model. So magnesium 2 plus. We're going to have 2 electrons in principal energy level 1. And then 8 in principal energy level 2. We don't have any in level 3, so we'll just leave that one off. So we can see the differences between the atom and the ion when we look at both the electron configuration and our Bohr models. So we can do a couple of examples here. So the lithium atom, we look at our periodic table, we see that it's got 3 protons, which means it has 3 electrons. And it's going to have an electron configuration of 2-1. So if I draw this, I'll have 2 electrons in level 1, and then 1 electron in level 2. Lithium plus 1 ion, I'll still have 3 protons, and to get a plus charge, I need 2 electrons there. My new electron configuration, I'll lose the electron from my outermost valence shell will be 2, 0. So my lithium plus 1 ion will have 2 electrons in shell 1 and no electrons anywhere else. I can do a similar thing for oxygen. Oxygen has 8 protons and 8 electrons. Its electron configuration is 2-6. So when I draw my Bohr model, I have 6 electrons, and that N equals 2 principal energy level. If I have an O minus 2 ion, I have 8 protons, and now I'll have an excess of electrons, so 10 electrons. When I look at my electron configuration, I'm going to add electrons into the valence shell. So I'll add those 2 extra electrons out into my valence shell. So when I draw my Bohr model, 2 on the inner shell and 8 on the outer shell. So I've filled up my outer shell of my oxygen atom to make an oxygen ion. Okay, so valence electrons are the electrons that inhabit the outermost energy level on an atom. We can tell how many valence electrons there are by looking at the electron configurations for each atom on the periodic table. And if we start to add or remove electrons, that's going to happen in the valence shell. And we can depict those with Bohr models and new electron configurations. Good work today. See you next time.